Good morning, class. We are Team 4. I'm Amar. I'll be your narrator today, and I'm joined by my teammates Lakshman and Siu. Our team analyzed Expedia hotel recommendations, which was posted originally as a Kaggle challenge earlier this year. Our agenda today will be to outline Expedia's business, the business problems that they are facing, a description of the data that we were given, some descriptive statistics that we gathered from the data, some analytical methods to possibly solve the problem, the final approach that we chose, and the implications that this method can have on Expedia's business. A brief introduction to Expedia. It is the national leader in online travel. In 2015, it had 12.6 market share. The nearest competitor was Priceline with a 5.5% share. Furthermore, last year, 69% of its total revenue came from online hotel booking. In general, Expedia would like to optimize its recommendation system on the website. It does this through 100 different hotel clusters, which are determined through various factors such as price, customer ratings, and location. For our data set, we were presented with a large data set that contained over 30 million rows of user data from Expedia's website since 2013. It contained 24 variables, some key ones which included things like unique user IDs, a timestamp for each visit the users made, location data for the users and the hotels they searched for, check-in and check-out dates, number of adults and children rooms requested, and binary variables to measure things like mobile use, bundled packages, and most importantly, whether or not the visit resulted in a booked hotel reservation. Key from this is that these variables are meant to be used as predictors for what kind of hotels that Expedia should recommend. I mentioned the clusters. These factors help determine which clusters to recommend. Ultimately, Expedia would like to use this data to predict the top 5 clusters in order to recommend to its users. So first, we gathered some descriptive statistics, and I'll share with you the key ones that we gathered. So we took a sample of the original 30 million, plus 30 million rows of data. We took a random sample of about 100,000 users, out of which there were 3,478 unique user IDs, 38 different Expedia sites used from around the world. So, for example, Expedia.com or its UK counterpart, Expedia.co.uk. There were users from 123 different countries, 510 regions, and 3,751 cities around the world. Just over 26,000 users used Expedia as part of a package. So, for example, a bundled package through a flight reservation or a car rental. Of the destination data that was searched, there were over 5,000 search destinations and 8 different destination group types. And out of the sample, approximately 9% of the users ended up booking through Expedia. And the users here searched for hotels on 6 different continents, 152 countries, and 1,531 metropolitan areas globally. Lastly, as you can see from the histogram, which is broken down by bookings per month, August and December are the most popular times of the year to travel. Next, we'll discuss about the analytical approach that we used. So initially, we decided to look at 2 main regression models. The first of which was a linear discriminant analysis. This is essentially a multi-class classification technique, which in this scenario would have been the 100 hotel clusters. The problem we encountered with this data set was that it contained too many categorical variables, while distance was the only continuous variable. In essence, while we had a categorical outcome, we didn't have enough continuous variables for this type of model to properly work. The second regression model that we looked at was a random forest. This is essentially a model that contains a multitude of simultaneously running decision trees and outputting the mode of the classes. However, we face programming limitations because R only accepts 53 levels in a categorical predictor, while also struggling to maintain proper symmetry in the categorical levels between the test and the training data sets. The approach we ultimately decided to use is evident in the screenshot that you can see that we took from Expedia's website. We decided to focus on determining patterns in user bookings and search criterion locations. Based on these patterns, we will determine a list of the top 5 in-order hotel clusters to recommend to users. For our test, we searched for similar patterns that were determining the training data set and thus outputted the predetermined top 5 clusters for each pattern. Some downsides of this method, though, however, are that measuring true accuracy of the predicted outputs is difficult to measure. Furthermore, user search patterns can be inconsistent for a variety of reasons, such as last-minute booking, cost, immediate availability, or flight delays or cancellations. For example, last month, a Cubs fan could have traveled last minute from Chicago to Cleveland to see the Cubs play in Game 6 and 7 of the World Series. As you can see on screen, there's a sample output of our model providing the top 5 clusters to recommend to unique users. We finish off with the conclusions that we gathered and the business implications that they have for Expedia and its users. So for its users, first and foremost, they receive increased personalized recommendations when booking. Furthermore, customers can book quicker and easier hotel accommodations. Lastly, they can receive rewards and discounts on bundled packages such as tours, cruise ships, flights, and car rentals. From Expedia's perspective, it is able to better segment based off unique selling point, competitive advantage, cost and savings. Furthermore, features like this allow for further differentiation from competitors in a crowded market. Lastly, the improved user experience can potentially lead to more traffic on Expedia's websites, which not only leads to more business for itself, but also provides further online data from users to continue to improve its services. Thank you for being a great audience. We now open up the floor to any questions you may have. Thank you.